Guys, and welcome to the section 1 of artificial intelligence, going the no-code route using Autogon AI. So for section 1, we're going to be exploring data growth, trends, and ethics, and we'll be looking at some super interesting AI demos using Autogon AI, solving day-to-day problems. And so here's the table of contents for section 1. We're going to be analyzing present surge in data, look at some global problems that requires intelligence. And yes, we're going to do some class quiz. And yes, why intelligence? What is intelligence? Why do we need extra intelligence? What is artificial intelligence? What is machine learning? What is deep learning? It's very important to understand context and relationship that exists between each of these derivatives. Some current artificial intelligence trends, a concise artificial intelligence historical perspective, and ethics and some practical demo. Okay, analyzing the present surge in data. If we look at chart 1, number of internet and social media users worldwide as at October 2023, we'll notice an interesting surge. So internet users, we're looking at a 5.3 billion users, and social media users, we're looking at a 4.95 billion. And the total number of people on the internet, you're looking at about 7.8 billion people approximately. So if 5.3 billion people out of the 7.8 billion people that exist on planet Earth, then you can understand internet penetration and the number of people who are coming online. And yes, we can see a good number of people who are coming online are also engaged with social media. So social media is actually a very powerful tool to reach internet users. Some of them might not even be savvy with using search engines like Google, but we can see social media has a very strong touch point with the number of users who are coming online. So graph 2, we can see the volume of data and information created, captured, copied, and consumed worldwide between 2010 to 2020. And so if you look at the trend, you see a very interesting geometric trend, especially between 2015 and 2018-2019. So we can see how the curve is going in a very geometric manner. There is very heavy data growth. The number of people who are generating content is very high. The number of TikTok videos generated, the number of Instagram videos generated, number of emails sent out, the number of video calls on WhatsApp, on FaceTime, the number of digital activities, logs, search histories, and all of that. So lately, you even find from some little social media analysis, you see that more users are more inclined with posts that has media content, either an image content or a video content or whatever. So and the data size of a media content is higher than the data size of a text content, characters. Yes, we're going to look at data size in a jiffy. But yeah, so this is just to show you how geometric things have been. If you look at between the era of 2014 and 2015, we were still akin with small size phone, the likes of Nokia, BlackBerry. And if you see the data generated for phones like that, those J2ME enabled phones and more, you see the data consumption, data generation very small. You take a picture, you can take a picture of 3 kilobytes, but now you're taking a picture, and if you check the size of the picture, sometimes you see up to 5 to 8 megabytes. All of these are adding to the number of digital data. And even as more devices come in, you see phones nowadays are having up to a terabyte of storage. Back in the days, you find kilobytes in storage, 10 megabytes in storage, but now a terabyte in storage. Now on a single phone for a single individual, and some people have much more than one phone. So imagine the age we are. Data is generated in a very high volume, and graph 1 shows how the number of people who have come online number of people who are coming online from the total population of the world, and the number of people who are engaged with social media. So yes, cool. So if you look at section 3, yeah, research conducted in 2016 estimated that 1.7 megabytes is how much data is created every second per person. So if you look at this research and you're looking at 1.7 megabytes created every single second and multiply it averagely by 5.3 billion internet users. If you want to be conservative, let's say you work with 3 to 4 billion users, and you multiply 1.7 megabyte by 3 billion or 4 billion, then you imagine the size in megabytes or gigabytes that is generated every single second. And this research was conducted in 2016. So with the advent of Industry 5.0, we are on the cusp of an era where technology will become even more integrated, interconnected, a vast array of devices and objects in our environment. Oh, beautiful. So Industry 5.0, which is the next paradigm shift, with this 5.0 is bringing interesting sections of technology that has to do with IoT, that's Internet of Things. And Internet of Things, you begin to have objects around you fully connected, like your microwave connected to the internet, your fridge is connected to the internet, your television connected to the internet. Yeah, 4.0 is already giving people power to connect some of these devices to the internet. But 5.0, Internet of Things penetration is going to grow in much more deeper. Not just your phones and your laptops will be connected to the internet, even your house. Yes, your house. The central control system connected to the internet, and many more. You have dogs. You have a smart device that checks those dogs, check the size of the portion of food left for the dog, monitors the dog every single second. So that same device is also going to be connected to the internet in line with Industry 5.0. Then you can imagine if we have all of these things connected to the internet, and we are generating, by then I don't think we're going to be generating 1.7 megabytes. We'll be generating way more than. But imagine all of these things are generating 1.7, 1.7, 1.7. Then imagine the data size. Good. Section 4. Big data market size revenue forecast worldwide from 2011 to 2027 in $1 billion. Yes. So data is the new oil. There is a lot of wealth that is going to be so individuals who know how to process this data and harness the power of this data in transforming processes, operations, maximizing revenue, and all of those stuff are going to be the one who are going to benefit from this particular start. And that's why you find the AI war between US and China, the world power guys. So yes, data is the next oil, and countries that do well with processing data, that have data in their full control, they can control all of the things, all of the objects, all of the behaviors, all of the constituents that makes up that data. And I'm going to show you why in this course. Okay, so some global problems that requires artificial intelligence, that requires intelligence. Climate change and environmental conservation. So yes, there's a pertinent challenge with climate change. If you follow World Economic Forum, you see some interesting articles and reports that talks about climate change and some major hazards that the Earth is going to witness if we don't do things right. Yes, from the number of CO2 emission that we are pushing down to the cutting down of our trees and so many spills that we are dropping into the water. There are just so many things that we are doing that is killing our Earth, especially on the CO2 emission. So yes, so there's need to do a lot of cutting of our CO2 emission. Then also the CO2 that has been emitted already on the atmosphere. We'll find a way to extract a large chunk of it, and yes, process it and turn it to maybe one other substance, and or put it under the ground, or process it into something that becomes useful. But yes, there's need to cut down on our CO2 emissions from transportation and every other area. But aside CO2 emission, there are some other interesting gaseous gases that are being emitted to the atmosphere, and it's a problem. Yes, and these things are polluting our ozone layer and will be causing a lot of hazardous effects to humans. Health and disease control. Yes, for those of you who were born 2 years and above, you would have witnessed the whole coronavirus thing. Beyond coronavirus, there are so many questions in health space that we've not been able to solve. See the likes of cancer. Cancer is still a very big problem. There are different types of cancers that are very, very disturbing, and yes, and it's killing a lot of people. Aside cancer, there are some like HIV/AIDS. We've not been able to fully cure HIV/AIDS and some interesting more diseases. Yes, so there's need for extra intelligence, leveraging computer intelligence to come aid us solve some of these interesting problems. Agriculture and food security, from food processing to maximizing the minerals the crops are going to yield, down to manipulating the genes of those crops, down to understanding climate change, what to plant, predicting the number of yields and all of those things. So there's need to bring in extra intelligence into our agri space and food security space, so it can aid us process more items properly, find better chemicals that will help aid us with preserving some kind of foods. Yes, without even naturally, even without leveraging much chemical controls and all of that. So we need intelligence to come into our agriculture and food security space. Even with the high growth rate of the number of people on Earth, yes, we need to ensure that our lands are yielding much more to be able to service the number of people we have on Earth. Education, yes, some countries see as suffering very much due to deprivation of knowledge, and it's a challenge. Yes, we need to leverage extra intelligence to see how we can extend knowledge, we can extend light to all of those remote countries. Yes, we extend knowledge. More people get more informed, and yes, knowledge. So this will get more informed. They know how to maximize operations and processes and things around them, and yes, even as they expand their yield. Transportation and urban planning. Yes, urban regions are well dense. Our transportation system, there's need to come up with some more innovative solutions, cutting down the travel hours between destination A to destination B, moving people much more safe, identifying bad roads and clearing of those roads. Intelligence, computer intelligence can come into our day-to-day beyond each of these five segment of problems I've just showed us. There are so many more problems artificial intelligence can help us do. Yes. Okay, so going deeper into artificial intelligence. So if you look at the screen right now, if I say spot the odd dog, find the odd dog, some of you might take a while to find it, and some of you might not. But this is an easy task for a machine to spot the difference. So understanding and spotting slight differences like this is where machines really, really excel in their performance, does better job than what humans would do. And if I show you, as you can see, this particular dog, every dog has the ear here is darker than the ear here, but this particular dog, this ear here is lighter than the ear here. That's for quiz 1. If it says spots the odd cheeseburger, yes, some of you again will struggle to find this. But yes, here is the odd cheeseburger. So we can see This does not have this green layer. This green layer does not have it. Oh, I'm not a burger person. I don't even know what the green layer. Maybe. I think they're vegetables. Okay. Quiz 3. If I tell you find the fraudulent transactions, looking at this CSV of data, so we can see this CSV has several records. You can download these data sets from this source. This CSV has several records. If I say spot all fraudulent transactions, it becomes so messed up. Here we're asked to spot cheeseburger, and yes, some of you really struggle with it. And more or less, when you're provided millions of transactions, billions of transactions, and you're meant to spot all fraudulent transactions, or for every single transaction that's coming into an institution, you're meant to spot if that transaction should be honored or not, if it's a fraudulent transaction or not. It becomes very difficult. And this is where artificial intelligence excels, does way better job than humans, by understanding each of those tiny data patterns. Yes. What is intelligence? Intelligence is a complex and multidimensional concept that is often defined in various ways depending on the context. In general, intelligence can be understood as the ability to learn from experience, adapt to new situations, understand and handle abstract concepts, and use knowledge to manipulate one's environment. Let's understand each of these key points. Intelligence can be understood as the ability to learn from experience, adapt to new situations, understand and handle abstract concepts, and use knowledge to manipulate one's environment. These are very four strong points that has to do with intelligence. And yes, some key aspects of intelligence includes learning ability, problem solving skills, adaptability, memory, understanding and handling abstract concepts, creativity, and emotional intelligence. And why do we need extra intelligence? A friend of mine reached out to me and said, but David, we have over 7.8 billion people in the world. Why do we need extra intelligence? Why do we need intelligence of machines? Enhanced problem solving capability is a challenge. Yes, AI can process, analyze data at a scale and speed beyond human capability. Like I showed you the Excel sheet and I say, find all fraudulent transactions. You, as a human, jumping on this document, your error rate is going to be extremely high. But artificial intelligence jumping on that particular document, it can find all of those things in split seconds, solve that business problem in split second, increased efficiency. So because it's able to do these things faster, smarter, at lower cost, it brings about efficiency for businesses. Yes, AI automates routine tasks, boosting productivity in industries such as manufacturing, logistics, and many more. The finance space, the agriculture space. This leaf has so and so disease. Pour water, pour lime, pour this, and you're fine. AI coming in to agriculture. If you look at the finance space, should this transaction be honored? Should this loan be approved? How much should we allocate to this particular person who has requested for XYZ loan? Yes, increased efficiency, making very strange, smart decisions that would have taken a human days and hours to solve. AI can solve these problems in milliseconds, and that is a major efficiency boost for any business that leverages artificial intelligence. Improved decision making. With the ability to rapidly analyze vast data sets, AI can support more informed decision making in critical fields like finance, policy making, and urban planning, innovation and development. Yes, AI can collaboratively working with humans trigger newer innovations, help us do things in a more better fashion, solve complex problems for us, like drug discovery. coming up with a new drug formula. Yeah, mixing billions of formula and coming up with a new drug formula that's not going to be hazardous, that's not going to be destructive to the human cell. AI can do a lot of research on it. Also, innovation. Yes, we can collaboratively working with AI, artificial intelligence, we can churn out much more innovative solutions that is going to advance our experience as man. Personalization and accessibility. Yes, AI can personalize experience of every single customer for a business, understanding the data patterns, understanding the customer behavior from each of the data patterns, what he likes to do, how long he spends on the app, how much he likes to transact, what time he likes to transact, what is the velocity of his transaction, the frequency of the transaction, where does it send, frequent destination his transaction goes. AI can solve all of these equations for each of a business customer all in split second. What is AI? Yes, artificial intelligence refers to simulation of human intelligence in machines or computer systems to perform tasks that typically require human intelligence. Prior to now, even till now, there are some banks who are still operating in the banking 4.0 framework. Some are still on 3.0. And then you find one very old elderly man who has spent 30 to 40 years in the bank, who studies all loan requests manually. And he takes him 8 to 9, 10 hours for him to say, oh, this loan should be approved, sometimes more than 24 hours. For him to say this loan should be approved, oh, based on the pattern of this customer who has made this request, I approve this loan or I decline this loan, or this is the amount I should give. AI has solved such problems, simulate all of, in fact, what 20 of such individual is going to do, one smart AI solution can do 100 of such 100 humans put together trying to solve that problem, and doing that problem will not be as fast as one smart AI you put that solves this problem in split seconds. Yes, such as understanding natural language, recognizing patterns. Yes, pattern recognition is a big deal. Solving complex problems, making decisions. AI aims to create systems that can think, reason, learn, and adapt often in ways that mimic human cognitive processes. Don't worry, AI is not going to take your job. What is machine learning? Machine learning is a subfield of artificial intelligence that focuses on the development of algorithms and statistical models that enable computers to learn and make predictions or decisions without being explicitly programmed to do so. Yes, so subfield of artificial intelligence with some super interesting statistical models. Yes, we're going to be looking at each of these statistical algorithms and how to bring it in full, or bring it in full control of our command. Yes, processing our data and understanding super interesting patterns. Yes, and there are several sub branches of machine learning, like the unsupervised learning, supervised learning, reinforcement learning. Unsupervised learning, you find subs like clustering, there's anomaly detection, dimensionality reduction, and more. Supervised learning, look at classification and regression, and there are several sub items you can do under classification, like identity fraud detection, image classification, customer retention, diagnosis, hemorrhage detection. Oh, classify, does this brain CT scan have hemorrhage or not? Looking at regression, yes. Weather forecasting, market forecasting, sales forecasting, population growth prediction, and more. Yes, and I will explain all of these things even as we go further into the course, and when to use each of these algorithms, and using these algorithms to solve interesting problems in your day-to-day for your business and earth-related problems. What is deep learning? Deep learning is a subset of machine learning. that is inspired by the structure and function of human brain, particularly neural networks. So machine learning, we're talking about statistical algorithms, but deep learning, subset of machine learning that has been built in the structure of a human brain. And you can see how this particular cell works. You can see this is the cell body, human brain neuron. This the synapse, the dendrites, the axon, and the cell body. This is how a single neuron today in the human brain. This is the structure of a neuron. And look at the structure of a deep learning neuron. Yes, you can see the dendrites, same dendrite here, and then we can see the cell body, and yes, the number of inputs. So each of these things collect inputs and pushes out output here, collect inputs, and then we can see this is the activation function, like the stick, like the root, whatever name you want to call it, and yes, the outputs, the synapse. And you can have in the human brain hundreds and billions of neurons all interconnected, passing electric signals and trying to make smart decisions per time. And that is how deep learning has been structured. Yes, following scientists have been able to model deep learning just like the human brain. Yes. So deep learning algorithms use artificial neural network with multiple layers to automatically learn and extract hierarchical features from data. This neural network consists of interconnected nodes or neurons that process and transform data as it flows through the layers. Yes. Good stuff. So it's time we explore the relationship that exists between each of these constituents, AI, machine learning, and deep learning. Already, we can see this particular chart, and then we can see machine learning. Deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence, and this is the relationship. Development of smart systems and machines that can carry out tasks that typically requires human intelligence. Machine learning creates algorithms that can learn from data and make decisions based on patterns observed, require human intervention when decision is incorrect. Deep learning uses artificial intelligence, artificial neural network to reach accurate conclusion without human intervention. Beautiful. And yes, you can read more about each of this relationship and when to use what ML systems use statistical techniques to automatically learn patterns, relationships, and insight from large data sets. And here, deep learning has shown remarkable performance in tasks involving complex, high-dimensional data such as image recognition, speech recognition, natural language processing. And you can see AI. AI aims to create intelligent systems or machines that can perform tasks that typically require human intelligence, such as reasoning, problem solving, understanding natural language, and making decisions. Okay, so here we're looking at some current artificial intelligence trends. So chart 1 here, we're looking at so it's a Bloomberg Intelligence and IDC. So the source of this particular chart, and we can see revenue as against here, and we can see there's a very fast growing revenue of generative AI, artificial intelligence. So meaning the payouts coming from the market for generative AI is growing and is growing exponentially as well. And this is a beautiful chart on why you want to quickly jump into artificial intelligence and yes, and get your cut out of this. even as you solve the world's biggest and interesting problems. So chart 2, we are looking at CO2 emission benchmarks, and we can see air travel from New York City to San Francisco, one passenger, and we can see the CO2 emission. We can see human life CO2 emission, American life average 1 year. We can see CO2 emission. We can see US car manufacturing and fuel consumption. We can see CO2 emission. And we can see training an AI model. And we can see the CO2 emission. So yes, man still has a lot of problems to solve. And even as we are building models, we can see that it's still generating high amount of CO2, and we need to fix this. Yes, cars transportation is generating high amount of CO2 as well, same as the industrial sector. But we can see those servers that we are using to train AI models also are generating a lot of CO2 emission. Chart 3, we can look at EU Artificial Intelligence Act based on risk level, minimal risk, limited risk. So you can see under traffic lights, surveillance. So limited risk, you can see impersonation, chatbots, emotional recognition, biometric categorization, deepfake, limited risk. Can see high risk, access to employment, education, public servers, safety components of vehicles, law enforcement, and etc. High risk. And unacceptable risk, social scoring. Oh, this is for EU. In China today, we have social scoring AI algorithms working in line with their mass surveillance, unacceptable risk, manipulation of behavior causing harm, unacceptable risk. So it's important you understand what is happening in the terrains of artificial intelligence on a global scale. So yes, we can see different countries, and yes, their engagement with artificial intelligence, machine learning, and neural networks. Yes, the source for all of these things is also provided with the PDF. Yes, the course material. A concise artificial intelligence historical perspective. So let's look at chart 1, and we can see from the 1600s down to 2018, first mechanical calculating machine built by French mathematician and inventor Blaise Pascal. Beautiful, beautiful. We've been on this journey of intelligence, and man has constantly continued to move the wheel of change, bringing in more intelligence to devices, from calculating simple arithmetic to devices performing and beating the Turing, that's the Turing challenge, the Turing test of if a device that differentiates a device from a human being. You can see 1837, first design for a programmable machine by Charles Babbage, and we trace it down to the 2009. Google built the first self-driving car to handle urban condition. 2002. I want something closer to 2000. iRobot launches Rumba, an autonomous vacuum cleaner that avoids obstacle. 2002. Then Google, 7 years after, computer program Deep Blue beats World Chess Champion. Okay, this is 1997. 1997. Okay, I'm trying to spot this down to 2011. IBM Watson defeats champions of US game show Jeopardy. Down to 2016. AlphaGo beats professional Go player And 2018, most universities have courses in artificial intelligence, and this this knowledge base, equipping our universities with artificial intelligence, now giving room for much more innovation, like what we have today in the generative AI space. Yes, and even the functional models we used to build in time past, we can then build synergy between each of those models and generative AI models, and greatly empower whatever autonomous system that we're trying to do with much more interesting intelligence. Okay, so section 2, similar history, but this comes from 2012 AlexNet, computer vision switches to neural networks. 2016 AlphaGo, yes, 2016. Here also we have the AlphaGo. 2017 transformer architecture. This architecture is a major change that came into our human comprehension, machine comprehension of text. Yes, machine comprehension of text. So this is a major advancement in the NLP space. The transformer architecture that gave birth to what we have like GPTs today. So you can see GPT-1, BERT, Graph neural networks 2018. As a result of this transformer architecture, then GPT-2, GPT-3. Today we have GPT-4, and and GPT-5 is on its way to come. And we can see the Alpha Fold in 2021, DALI 2, GitHub Copilot. We have many more other industries that have pushed their own Copilot as well. Including Microsoft. ChatGPT Stable Diffusion, interesting Gen AI project, and a lot of things around generative AI, like Mistral, like Phi 2, so many more generative AI projects and models you will find today on Hugging Face, both open source projects and private projects. So some importance of artificial intelligence. Drug discovery. Yes, it's very important that we also leverage the intelligence from machine to boost chances of innovating new drugs that will solve our current health concerns today, like the HIV space, coronavirus, and many other health related issues that today we've not been able to find a cure for them. So leveraging AI will speed up the process of achieving the cure for this interesting stuff. And there's some interesting stories already with AI discoveries in the area of health. Also, AI personalized medicine. Imagine, in fact, no need to imagine. Every single thing you have functional in your body is a system. And because your body is a system, it generates a lot of data, a lot of logs. So the ability to track all of these logs that has been generated in your body, from your nervous system, your central nervous system, down to your legs. We track all of this data that has been generated. We understand the patterns of every single thing. And when there is a pain that's happening at the back, we will understand what has caused the pain, what cells has triggered it, and what liquid have those cells released, or wherever what's growing at that particular spot. So we understand all of these things. We can create a personalized drug or a personalized medicine for that particular patient by analyzing the patient's body, looking at the logs and the data of each of the systems and every single thing. We can generate a personalized medicine in the right constituent that is going to address that particular ailment. Today we've been able to conquer malaria to a very great deal. but we've not still done very much well. Like, yeah, we still have a long way to go, because you still find malaria patients take drugs. You take it morning and night, morning and night, morning and night, especially in Africa, and you still have malaria, and you're taking drug a dosage for 5 days, 6 days, 7 days, 8 days. But with personalized medicine, the machine can produce the right constituents, and just one pill can fix that particular human up. Yes, so the machine produces the right constituent, taking into consideration that the right constituent for that particular human system, taking into consideration the human system, the age, the body size, the amount of liquid, and many more others. So the machine studies all of those things and produce something very particular to that human. This is going to change the health space. AI fraud detection. Even as more people are coming online, businesses are receiving a lot of data logs. How do you know what transaction is fraudulent? What transaction is going to take your network down? What transaction is going to kick against your compliance? And this is where fraud detection comes in, from the KYC, compliance, and many more other detection, anti-money laundering, velocity attack, capturing transaction fraud with several transaction monitoring techniques. AI can do all of these things for you seamlessly. Yes, I'm going to show you how to do that in the course of this journey for this course. Autogon AI chatbot and robo advisor. Yes, beautiful age of artificial intelligence. AI kicking off, working very closely with businesses in the area of customer service. Humans can now enjoy personalized attention and have that personalized attention always. And yes, businesses now having much more control over customer retention with chatbots, robo advisors. A robo advisor customer, digital customer chatbot is just always available to speak to that customer, to advise that customer, not just waiting for the customer to trigger a conversation. Oh, I just saw you spend the money. This money is for what? Remember, you have a savings plan. I'm keeping my eyes on your savings plan because the goal we have is to meet so and so target. So the AI working very closely with each human, personalized experience, personalized conversation for A, for B, for C, for D. Yes, interesting times in line with Industry 5.0. AI predictive maintenance. Yes, understanding machines, the maintenance life cycle, when last it broke down, understand when last it broke down, how long it took it to get it repaired, and all of those data it generates as to number of time it takes it to work. We can put all of these data together and predict the next time that particular machine is going to break down from analyzing the past history of the machine. Yes, and it's not just machines you find in the industries, including aircraft parts. So even vehicles that you're driving, yes, predictive maintenance, predicting when this car is going to break down, and it's going to break down by so and so time. So the car is already advising you what to do, and it's just capable of self-fixing itself. Yes, these are REMs, some importance of artificial intelligence. The artificial intelligence is going to be bringing to human AI livestock monitoring. Yes, with artificial intelligence in the area of computer vision, we can give more interesting attention and visibility to our cattle, and this is very important. So looking at ethical considerations in the realm of artificial intelligence, there are a couple of items you want to work with in mind. So there's the whole bias thing, and bias. When you're fighting bias, you look at it from data bias. There's algorithm bias. Yes, digital platform regulation, ethics, what you should be done, tooling for interpretable AI. Yes, I'll show you how you can use the likes of Sharp to understand why your model is predicting what it's predicting. Laws, what is forbidden to do. So there are different laws. I've showed you regulation about artificial intelligence in the EU region, on live rights, IP protection of AI models. You want to be very careful with that. AI tools for making regulation, AI tools for regulation making. So you want to check out this link here, as I have the link here opened, and you can see how does bias and privacy breach happen. AI bias, data bias happens when AI models training data is unrepresentative or biased. Yeah, so the AI model may reinforce biases in judgment and predictions if the training data is distorted or prejudiced. So there's a classical scenario I have in my head. Let me just tell you around bias. So there was this institution that built an AI model that has to do with that handles recruitment, and the AI model was more biased to male gender. Saw them more to be stronger, better, faster, and more equipped to jump on those jobs than female gender. So there are several regions for bias, like you see some surveillance cameras that classify people of color to be criminals. Those are data bias challenges. Then algorithmic bias. So our biases induced during the design and implementation of AI algorithm. This happens when the algorithm is incorrect or when it is created with specific assumptions or preference that results in unjust outcome for some group of individuals. Or algorithmic bias, Autogon AI has taken care of a lot of these items. So privacy breach. The AI privacy breach occurs when AI systems improperly store, access, and exploit data without users' permission. So here you can see that here. So you want to ensure you have the necessary compliance regulation. You follow the bylaws of the economy that you are providing that particular solution, whatever data you're collecting from the end users, and what are you doing with those data. Very important. So yes, so going in line with code of conduct tells if you are ethical in your nature or you are not ethical. You can read this, go through this particular article. It does very good justice to talk of AI and ethics. Rise, it just does a very good justice. Beautiful, beautiful. Then good. So over to section 1, practical demo, and we are going to be running demos across each of these content area. So this is a machine learning problem, this is another machine learning problem, this is a computer vision problem, vision problem, this voice cloning problem, and here we're going to be building chatbots leveraging Gen AI. So to follow me, to work closely with me even as we get this done, ensure you download this resource because it has some of the resources we're going to use with inferencing these models in each of these areas. So so very quickly, I already have Autogon AI portal open. So to get started, for those of you who just be creating an account, you visit autogon.ai, and yes, when you click on the get started for free button, you get access to $100 credit to access all Autogon AI products. Yes, so if I click on login, I'm already logged in, and yes, if you're not logged in, it takes you to the registration page where you enter your details and you register and you get access to free credit. And for those of you who prefer other languages like Arabic, Chinese, Dutch, French, German, Hindi, you can always switch the language preference here to what suits you at every point in time. Beautiful. Okay, so we're going to be starting with the first challenge here, which is health risk assessment. So I'll copy this data link here, and I'll click on data sets, and I'll create a data set. I'll paste the URL here, and I call this health, okay, section 1, and I call this health risk assessment. Yeah, just give it a short name, and no need for a cover image. Description, I can just enter the same thing here, and I create the data set. Beautiful. So if I click on this and I view the data sets, we can see, oh, it's a data set that has 1,000 rows and 5 columns. Beautiful. And you can see the column names: age, medical condition, lifestyle, genetic markers, and health risk. And so for this particular data set, we need to build a model that understands the relationship between each of these columns and the health risk. So meaning each of these columns will serve as our independent variable. We're going to go deep dive into each of these things in clear terms. So each of these columns will serve as our independent variable, and health risk is the dependent variable. So independent variables are column names that you put together to try to deduce the relationship with the dependent variable. So we're trying to predict for health risk. So the finalization of this model, we're going to build a model that understands the relationship between all of these in line with the health risk. And when the model has been fully built, new users who are registering, so for this business, this can be an insurance company. So when a new user registers, enters the age, enters medical condition, 0 means no medical condition, no threat, 1 means yes, lifestyle, yes. So a couple of form, the health insurance as provided to the end customers who are filling this form, and in line with that, they ranked the lifestyle 0.73. So the higher it is, the person does better. Genetic markers, then health risk. 1 means this is a high risk, and 0 means low risk. Good. So if you look at this health risk column, you can see 1 and 0. Yes, so those are the only 2 items you find on the health risk column, 1 and 0. And when you are solving problems like this, true or false, male or female, yes or no, fraudulent or non-fraudulent, those are categorical variables. And when you are solving categorical variable challenges, you are going through the route of a classification problem. So yes, you're trying to classify gender, you're trying to classify is the switch on or it's off, you're trying to classify, okay, what level is he. So those are various classification problems. And yes, you'll get a very good deep dive into all of these things in the next course, yes, in the subsequent course. So this is just high level. So now we are going to be building a machine learning model, a classification machine learning model based off of this data set, that the model is going to understand the relationship between all of these things. Then when a new transaction is coming in, so after the person has inputted some other items that was used to generate this and this, our model will be able to predict if the person who has all of this thing is a risk for the business. And if it's a risk, the insurance company can decide to heighten the premium price or reject such patients, because those kind of patients are going to run the insurance company to loss. Okay, beautiful. So we would create a project. I'll click on projects, and I'll create a project. I'll call this section 1, and health risk assessment. And yes, you can paste similar thing for the description, but you want to enter a detailed description. Good. So there are two interesting products on Autogon AI you can use in building a classification model, a machine learning model. So you can either go through the Studio Wizard, or you can go through the Autogon Studio. So this is Autogon Studio. So Studio Wizard is a no-code auto AI, auto ML tool, where you just drag in your data set, and in 3 steps you are able to build a powerful machine learning model in 3 steps. Click, click, click. And you can also do the same thing via an API, but in 3 steps you can build a very powerful machine learning model going through the route of a Studio Wizard. Then going through the route of a studio, yes, I'll show you all of these things in subsequent training. You'll be able to drag specific. Let's open Studio, so we just check it out. Oh, this is sample project. You drag data sets, you drag data splitting, drag this, drag classify train. If it's a machine learning classification problem, you can select the particular classification algorithm you want to use. You can use a random forest or a decision tree classification algorithm, and random forest classification, and all of that. But yes, we're not going to be using Autogon Studio for this particular problem. We're going to use Autogon Studio Wizard. So we'll launch Autogon Studio Wizard, and we select the particular data sets that we had created some minutes ago. And this is this. Don't forget, you can directly input the URL of the data set here if you don't want to create it. And yes, so let's just select the data set. We've just selected it. We'll give this some seconds to run. I'll show you how very easy it is for you to build intelligence. And yes, and you see how very easy it is to integrate this intelligence into your back office. So for those of you who have an app or any innovative product you're trying to build that leverages machine intelligence. Okay, so this data set analysis, before you build a model, it shows you if there are missing values, there are no missing values. It shows, you can see health risk is a categorical variable, genetic markers numeric, categorical, numeric. I will explain why it's a categorical variable. So you can see mean, standard deviation, median, and yes. So we'll click on next to go straight in building a model. We select classification because we are trying to predict health risk, and that's a categorical variable. Health risk, true or false, risky or not risky, high risk or low risk. That's a classification problem. Then we select target variable, which is health risk, and the name of the model, anything. You can give it version 1, version 2, but for the sake of this course, I'll just do PHR, prediction of health risk, or health risk underscore model. Yeah, anything basically. And we'll click on train. So yes, we'll give this some seconds to run. So what this AutoML tool does, it runs a couple of algorithms all simultaneously on this data set and look for the one that has the highest accuracy. Oh, beautiful. You can see our model is done training and we have an accuracy of 100%. So this model is very accurate. So confusion matrix, I won't stress you now on this. I will explain more detail what confusion matrix does, and we can see here. So true positive, model predicted all very well, and true negative, the model predicted all very well. Yes, and beautiful predictions. Model is very accurate. If we look at feature of importance, we can see lifestyle factors and medical conditions are two very strong feature of importance in determining the health risk. Yeah. So and yes, we built a model, and the model has 100% accuracy. So to inference this model and to integrate this model, yes, subsequent course you're going to really digest all of this, but we just run one particular inference of this model. So what we simply do is let's open these data sets. So we can see for this is data set we have here, and we can see 59, 0, 0.73, 0.23, and 1. So to inference this model, I'll copy all of this thing here. I will copy the 1. I'll copy it. And we're going to pass. So we'll treat this like a new transaction. Yes, we'll treat this like a new transaction. So we're trying to predict health risk. So this one here happens to be the health risk. 59 years the age, 0 is the medical condition, 0.73 is the lifestyle factors, 0.23 genetic markers. So I'll pick all of these. You can see before that comma, and I'll copy it. We're going to inference this with the model that we've just built. Okay, so for you to, you can see we click on prediction, and we need to enter test data. Now Autogon does not support entering this. You need to create a sample data set if you're coming through the portal, and one way to do it is just click on your data set here, click on the quick predict here, yes, and click on this create data set. We paste what we've just copied, select one dimension, and we generate, and we've just generated the data sets. So let's visualize it so you can see what we just generated, and you can see it's exactly what we copied: 59, 0, 0.73, 0.23. So now we have this. We can pass this to this input here, and we'll click on predict, and beautiful. Can you see the prediction label? The prediction label is 1, and this is the prediction score, 100%, which is 1. So yes, we can see our model actually predicted that it's going to be 1. So yeah, it's a very highly accurate model. So a new customer that's coming in, based on what our model has learned from the relationship between age, medical condition, lifestyle factors, genetic markers in line with health risk. Our model already understands that relationship, and our model can predict if those new customers are of high risk or they are of low risk. And yes, we can also inference our model via an API, and one way to do it is just we'll create a pipeline. And creating a pipeline here is simply we give it a pipeline name. So let's call this PHR underscore model underscore pipeline. You see how easy it is to create intelligence? Yes, it's that easy. So yes, we've just created a pipeline. Before we come out of this project, you can see we have a model with accuracy of 100%. But let's come out of the Studio Wizard, and yes, you can see on the project we created, section 1, health risk assessment, we can see pipeline has been created. All we just need to do is copy the pipeline. So copy the pipeline, but before we go, I'll show you how to access this pipeline via an API. But before we go through that, yes, you can also use Autogon quick predicts. So if I click on section 1. Yes, so you can see and you can see the model that has been created. But yes, we've created a pipeline. If I select the pipeline, we also created a dataset. Let's also pick the dataset and pass the dataset link. And if we click on run model, we can see what the prediction came out with 1, meaning this person has a high health risk. Yes, and this is beautiful. And this is something similar you're going to be doing via the API environment. Okay, so let's quickly launch our Postman. Okay, so right here I have my Postman open here. Right here I have my Postman open, and we are going to be accessing this particular data set. Yes, so we'll copy the data set. And we apply the data set. Yes, we need to copy this flow ID here is the pipeline ID that we've created. All we need to do is to click on the project. Click on the project that we newly created. If I click on the project that was newly created and I copy the pipeline ID, paste the pipeline ID here. Good. So I have the pipeline ID, I have the data. You ensure you have all forms of authorization here. And so if I click on run, yes, so we can see, yes, we have our prediction successful. You can see how many milliseconds it took to run that prediction. So this is a direct inferencing with your model. If I click on this prediction URL and I visualize the data set, what do you see here? 1, meaning this is a risky patient, and we need to take caution. And yes, you can generate your data set similarly via API. So if you're going to be calling the API here, you ask, okay, how do you generate this data set? There's a generate data set API, and you can see the way parameters are passed data. And so in our case, we'll be having something like this: data column and this, and we'll place every single thing in the quotes. Okay, I'll place every single thing in the quotes. Take off this other one, and yes, we have our data. And if we click on send, and you can see beautiful data set has been generated just like we did via the portal. And you can copy that data set and inference it with the pipeline. So I inference with the pipeline, and you get your value. And by the time we visualize our value, we'll get same 1. Yes. So this is how to build machine learning models. Super fast, super accurate, without stress, and integrate it into your product. So what I just showed you, I showed you how to build a machine learning model, a classification machine learning model using Autogon Studio Wizard, and yes, we got an accuracy of 100%. And I also showed you how we created a pipeline, which the pipeline is available here, and how you can inference the model through the quick predict here or through the Studio Wizard environment, and you can inference your model via an API. So if you have a back office system, inferencing here, you select the project, you select the pipeline we've created, and you enter the dataset link and you run. And if you say, oh, okay, I want to generate a new data set, you create data set, add the values, and ensure you select one dimension, generate the data set, copy it, and you're good to go. Okay, let's look at the second problem. So the second problem happens to be insurance claim analysis, demographic and health related. So let's copy this data set. We can also visualize these data sets similarly, and then we can see, oh, this is not so clear. Let's copy the data sets to Autogon AI platform. Paste the data set, and what's the name again? Insurance claim analysis. So I'll keep it same, section 1. Insurance claim analysis. Yes, I'm trying to keep it simple. Okay, and good. So let's visualize our data set, and we can see this is a data set of has 1,340 rows with 11 columns. So you can see index, patient ID, age, gender, body mass index, blood pressure, diabetic, number of children, smokers, region, and claim amount. Yes, and claim amount. So there's something beautiful you can even do with some of these data sets. Like the last one we did, we can click on visualize data sets, and you will see an auto-generated chart. All of these are going to be well explained in the subsequent training. So this is like a high level of some of the interesting features Autogon AI has, solving related to the demo, practical demo section. And then you can see heat map. I'll explain all of these things: distance, number plot, carve-out plot. I will explain all of these things, and then you can already start looking at some relationship between your data sets. But yeah, we're not exploring this for now. So looking at this particular data set, index patient ID, so we can see this happens to be an insurance company, and they have different records of different patients, their age, their gender, BMI, blood pressure, diabetic, if they have children, a number of children. Okay, let's check children. Let's check if it's, yeah, okay, if they have children, not number of children. So 0 means no, 1 means yes. Do they smoke? Yes or no? So we can see a lot of them don't smoke. Okay, yes, a lot of them smoke as well. Region and claim. Yes. So the insurance company is wanting to gauge the claim, and here we can see claim is not a categorical data, it's a numeric data, it's a continuous data. It's not a yes or no, it's not a black, white, green, it's a continuous value. And yes, so when you are solving problems that has to do with continuous values, you are actually going through the route of a regression. So we're quickly going to create a project for section 2. We'll call this section 2, and yeah, I think it was ICA. Give it section 2 ICA. I will create the project. Okay, so we'll click on Launch Studio and select datasets. We'll select dataset ICA, and we'll have this run. Give it some seconds to run. So this is the beautiful thing about Industry 5.0. Building machine intelligence and integrating machine intelligence should be seamless. You don't need a professional with 10 years of experience any longer. Okay, so we can see each of the columns, and yes, in line with data quality, high level feature of importance, and you can also see you can see claims in numeric variable, categorical variable, gender, boolean, diabetic, and yes, we can also see number of missing value. We can see this particular column each has 5 missing values. Region has 3 missing values. Let's check if claim has any. Number of missing values 0. Okay, so we'll click next, and we select training type. We select regression, and the dependent variable we're after is claim, and we give this any name. So we can either call it a claim underscore model, and copy this and train. We run this. It takes a couple of seconds depending on the size of your data set. So for those of you who are just jumping on NoCode, you can also try go through the route of writing raw code to build these models, and first thing, compare if you can get the same accuracy, and check the time taken to get the same accuracy, and integrate it into a new project, a new product. So before you write the code down into, our model is done running, and this is a very beautiful model. You can see the arrow2 score. All of this is going to be well explained in subsequent section. arrow2 score of 0.99, very beautiful, and we can see the loss, very beautiful as well. And so yes, so we can see our model has a high number of correct predictions, understanding the pattern of the data sets, and has some wrong predictions, not so clear, but this is a beautiful model. And if we look at feature of importance, we can see index and patient ID contributed the most to the feature of importance as to what we are trying to predict, which is the claim. So if we click on prediction, we can go through the same route by copying. So you can see this first row, index 0, patient ID 1, age 39.0, gender male, blood pressure 23.2, diabetic, blood pressure this, diabetic 91, and number of children, diabetic yes, number of children 0, smoker, and blah blah blah. So we copy all of this aside the last item here. We'll copy all of this, and we go create a data set that we can use to inference our model that we need to pass down here. All we need to do is we'll close this, click on this, and create a one-dimension data set, and copy this. We can visualize the data set here, and yes, you can see, yes, we have our data set. So come to our project, paste our data set link, and click on predict, and let's see what our model ended up predicting. Our model predicted 1164.26, and let's see what the data set has. 1121.87, 1121.87, 1164.26. So you can see this prediction is actually very close. So yes, so a new customer that's coming into the insurance, that needs insurance, so the insurance company is able to, from all of their patterns, from all of the data patterns that they filled up in the form, predict what's a likely claim this new customer is going to file. And customers who are going to file very high claim, you want to increase their premium or you want to avoid them, especially the ones who are going to spend more time in the hospital and make the insurance company go bankrupt. So yes, beautiful Beautiful. Let's run some more predictions. We can copy 82, this particular line. We copy all of this, and we come to this area of creating data sets. We create the data sets, select one dimension and generate data sets. We copy the data sets again, and we go to test data, paste the link, and click on predict. And yes, you see how fast it is, the inferencing is 1908.39, and you can see what we copy 1909.53. so you can see our model is actually very almost accurate with this particular prediction. So what does this mean? We've built an AI model that understands the relationship between the independent variable and the dependent variables, and the AI model has learned enough to be able to predict new transactions, not just transactions from the existing data set. So new transactions coming in to the insurance company portal, new registration coming to the insurance company portal. The insurance company can predict and know the likelihood of whatever is going to happen of that particular customer. So beautiful. So let's create a pipeline for this, and we call this any name basically. So we can just call it pipeline underscore claim, and yes, we'll create a pipeline. Beautiful. And we can exit this project, so we can also see the pipeline IDs here. Yes, we can copy it and go straight to Postman, but before we go straight to Postman, I'd like us to come play with it on quick predict. So for those of you who don't have a back office, you can select project here that you can manually copy the new customer who have registered and do the inferencing directly on Autogon platform. So I'll copy the link of the dataset for this particular new customer, and I click on run model, and you can see, yes, this was predicted 1164.26. Beautiful. So similar stuff I've done here. This, if I don't have a back office, I can test my model, and I keep inferencing my model from Autogon quick predict. And if I have a back office, all I need to do is to go copy my pipeline ID, copy the pipeline ID, and I go back to Postman. So I change the flow ID here, and I paste the new flow ID, and I'll come copy datasets that I've generated, and I'll replace what we have here, and I click a run, and beautiful. You can see we have our prediction URL, and by the time I visualize dataset, I can see the 1164.26, which is beautiful. So I can go on and on and on and inference and inference. You can see the time in milliseconds it took. Super fast, super efficient, and very available. So yes, we've been able to solve challenges with our health risk assessment dataset. We have also solved challenges with insurance claim analysis based on demography and health. So the next we're going to look at is hemorrhage detection from brain, BRAIN, brain CT scan. Good. So I will launch Autogon again. Now I already have a project that has to do with hemorrhage detection. It has to do with hemorrhage detection. I'd created already. So let's open the project. Head CT scan. Launch the project. So you can build simple to complex models, machine learning, deep learning, design deep neural networks on Autogon Studio, build deep classification models, image models, and more. But Autogon Labelcraft is specifically designed for object detection. So we'll launch Autogon Labelcraft for this, and So for those of you who are familiar with this happens to be a brain CT scan, and if you look at here, you can see multiple images I've uploaded already. Yes, I'll make this project and this data set available for every one of you. So you can see these are different brain CT scans of different patients. To upload a data set, all you need to do is to click upload files and select the entire file that you're wanting to upload. As simple as that. And once you have uploaded, so what we've done here is to label, yes, and you simply label by clicking on this is called bounding box, and you draw a bounding box on the region of interest. Here we're talking about a brain CT scan. You can build your label to identify different objects in your manufacturing plant. You can build your label to look at a leaf, a maize leaf, a rice leaf, or lettuce leaf, and spot different types of diseases. So all you need to do is draw a bounding box, select the region of interest, and tag it. So you create all the tags: this disease, that disease, skin disease, is seen, whatever. Create all the tags. So once you've drawn the bounding box, all you need to do is to tag that bounding box to whatever that you've created. But yes, I'll go ahead and delete this. Okay, so if you look at this, I have 200 images here, and you can see I have annotated positive, negative, positive, negative. You can see all these white regions are regions of the hemorrhage. Yes, so these are regions of the hemorrhage, has been annotated already. So it starts with you first step, you upload your images. Second step, you draw bounding box on the region of interest. You can look at the shortcut guide to use your keyboard command to do whatever you need to do, and then you can always select here and do whatever you need to do as well. So yes, I annotated each of these. You can see positive, and I train a model. And training a model here is just as simple as clicking this, enter. So if it's an existing model you want to retrain, then you specify the model name that you've trained before. But when you're training a new model, you can say leave empty to train a fresh model. You enter the name of the new model, and you enter the dimension. Leave 640 by 640 if you don't know what to put. And then epochs, you can leave your epochs between 5, 10, 20. So depending on how deep what you're trying to train your models to see. So there's some kind of medical images you want to train that can span even up to 100 epochs or 7 epochs. But yes, subsequent course is going to show you how to go around all of this. Yes, beautiful. And once you do this, and you click on next, you straight away go straight into training your model. And you can also augment as well. Subsequent course is going to explain all of this. And let's try to run a sample prediction, because I've built a model. I ran the model. The model took 40 minutes to build, to train. Let's run a test prediction on a new hemorrhage image. So if I select this and I inference this new hemorrhage image, I'll give this some seconds. Okay, so we can see our model inferencing has happened, and if we zoom this a little, we can see our model highlighted all the positive regions in this particular image, hemorrhage positive in this particular image. And yes, we can see the JSON annotations here. That's the response coming from the API. We can see the highest is 0.66, 0.61. So we can say, okay, let's filter anything from 40% and above, and let's see what the model is going to return. Good. So we filtered from 40% and above. So any prediction confidence is from 40% and above, and we can see the model has highlighted same regions. Yes, so if you have your back office, you can build an object detection model. Not compulsory, it must be in the health space, but yeah, it's important we solve our biggest problems facing humanity on earth. So it can be in the agriculture space, it can be in the logistic space, and yeah, different other sectors. And yeah, you empower train AI models with vision sense to be able to predict. So there's this bounding box here. These boxes here, and you can see X, Y, width, height. Yes, and confidence level. Just for those of you who have little programming skills, you can assess each of these things. And also, let me show you how you can also do an inferencing via Postman. So I'll quickly call up my Postman, and yes, we can see a sample request for inferencing. So you build computer vision AI models, and yes, you can inference these models from your own backend system. I can see you get to place the API URL, and you pass in your parameters. So here is the image. So you can inference more than one image by adding more than one here, and then you get response for more than one, and you can inference just one. So here I'm passing just one image, and that's the same image I've used while inferencing at this other region. And then I pass the confidence threshold, anything from 0.3, meaning anything from 30% and above, return all of the response. And you can see the AI model we built was able to return all of the response. 0.7, the model is certain that that's a positive. 0.7, that it's a positive hemorrhage image, and 0.4 positive, 0.47 positive, and so on and like that. Good. So that's that for building vision models on Labelcraft. Okay, so the next problem we're going to be solving, it has to do with optical character recognition. And yes, for optical character recognition, it's simply a technology that extracts text from image datasets, your document, and all of that. So let's hop on to Autogon core by clicking Autogon core here. You see detect text image, convert scanned document and images into searchable, editable text for efficient content management. If we click on this, the beautiful thing about this is there's documentation for this. You can integrate this into your back office, text and image, and here's the API. You pass the image, and then you get the text. And here we can see this happens to be an international passport document, a sample document that was passed in. When you create an account, you are going to see these sample items here. Yes, and so we can see block 1, and extracted the Federal Republic of Nigeria, blah 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 blah. So block 1 kind of extracted everything within this bounding box. Block 2 federal, block 3 this, block 4 like that. So you can then use very smart algorithms to extract. For instance, now you want to extract the passport number, you can use smart algorithm to extract the exact passport number. So let's check out identity card. Second example here. As we can see, similar item, block 1 extracted Republic of Ghana, blah 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 blah, and beautiful. And yes, you can see we extracted all of these items. So for a new file, you can so if you've downloaded the section 1 document, you have access to all of this. If I click on OCR and I click on this New York image, I can upload it, and you can see it has extracted all of this text from this particular image that we've uploaded. Let's upload something else again. Federal Republic of Nigeria, national driver's license. I will upload this. I will see what this service extracts for us, and we can see it has extracted information from this particular image. The next thing is so we can see this looks like the ID ADK037 ADK037 84AA02. So block 13 is holding the ID. So let's do one more, and okay, we've done this already. So beautiful. So this is about Autogon optical character recognition, extracting text from documents. So just small algorithms, and you can extract the exact text that you're looking for from any document. Beautiful. So the next item is core object detection. So yes, we're going to hop right back and click on label detection. And you can see this label detection was able to extract all of the objects and label them. So you can see brown color, whatever, plant, couch, furniture, building, azure, orange, wood, comfort, interior design. Yeah, so if we pass another image, it's going to extract all the objects from this image: car, wheel, tire, vehicle, registration plate, infrastructure, building, automotive design. So you can see when you're wanting to interpret and yes, bring in sites for a visually impaired individual, you can integrate services like this. And even aside that, you can integrate services like this beyond visually impaired individual, connected to your webcam, detect whatever, and yes, and build smart systems out of it. Tire, wheel, land vehicle, bicycle, photograph, car, bicycle equipment, supplies, motor vehicle, infrastructure. Good. So the next service we're going to be looking at is voice cloning. So voice cloning, we are going to clone our own voice. Yes, and kindly note that it's illegal to abuse this service. So what I've done here, I'd cloned my voice. I'm going to delete this and try to clone my voice again. Yes, so you record your voice by reading all of these items, so the model understands the texture of your voice to different stuff, and you can use it to generate a new sample voice via providing a text. So let's start. The Earth, our remarkable blue planet, has been a sanctuary for life as we know it. However, this sanctuary is now facing an unprecedented challenge: climate change. This phenomenon, primarily driven by human activities, is causing profound shifts in our planet's delicate equilibrium. Climate change centers on the alteration of long-established weather patterns, a consequence of human actions such as burning fossil fuels and deforestation. The outcome: a rise in global temperatures due to the accumulation of greenhouse gases in the atmosphere. These gases trap heat, leading to gradual but impactful warming of the Earth. The consequences are already evident. Glacial ice is receding and polar ice caps are melting, contributing to rising sea levels that threaten coastal communities. Extreme weather events like hurricanes and droughts are on the rise, wreaking havoc on societies and ecosystems. The very essence of biodiversity is at risk as species struggle to adapt to the changing environment. Oh, okay, beautiful. And I'll call this David voice. And yes, David's voice, and submit this. I have this saved. So submitting it, we're actually training the model with our voice, our cloned voice. So from all we've read, we can then pass a text, and the model will generate a cloned voice in line with our own voice. So we'll give this some seconds. Oh, beautiful. So it's done creating. So I select my voice here and I write, so let's copy this and we'll submit.
Experience the future of AI-driven personalization with voice cloning. Create lifelike replicas of voices to captivate your audience like never before.
Okay, so you can see that has the tone and the feel of my voice. I love you, and submit.
I love you.
I love you. Okay, so one more thing, voice cloning elevate your brand today. I'll submit this, and already you can already generate interesting sounds, and yes, interesting sounds.
Voice cloning elevates your brand to new heights. Embrace the future of personalized engagement with voice cloning today.
Beautiful. So you can integrate this voice cloning into your services, your apps, your books. You create a brand voice that resonates with your own voice, and yeah. So this is about the voice cloning service. And the last service we're going to be playing with on Autogon AI is chatbots. Chatbot build up and integration for section 1. So we'll click on chatbots, and yes, you can see I have a couple of chatbots here. For this particular chatbot, I trained this particular chatbot to understand my book. So I passed my book, and I trained it to understand my book, and I gave it the description of a digital assistant, digital version of a book at David, and I gave it this goal, and I gave it the goal. But let's train a new chatbot. So if I select, so use public LLM, public knowledge base. Public LLM, you're saying the likes of GPT 3.5, GPT 4. Private, you say Mistral, there's Llama 2 and all. So you enter the bot name. So we'll call this section 1 test bot. Brand color, I could leave this description. I can put anything here. Describe your bot. This is a test bot. Agent identity. This bot, we're going to train this bot. We're going to train this bot with this particular data set, African Med. Yeah, so it's an African medical doctor. You are an African medical doctor. You would keep your responses brief. Keep your responses brief, polite. Give users cure to their problems, to their health problems. Any question asked that is outside your context, kindly declare so politely. So the user, and we can select section 1 chatbots, African medical doctor, and slide 3. In fact, we could even select all of this, and I'll click on create. So we'll train the bot to understand every single item on those PDFs, and yes, users can query it. So if you look at this, medicinal plants and herbal medicines in Africa, Chinazagotwi Awuchi, keywords. So if you look at this, I don't really know much about this, but I can see, okay, is this ginger? Okay, that's not ginger. Okay, let's look at a different PDF. Okay, our bot is still creating. So okay, our bot is done creating. So the beautiful thing about Autogon AI service is once you've created a bot, all you need to do is copy this script here and paste on your website header, and you're going to have the bot pop up like this. Like this bot, I'd built this bot on every single documentation, developer documentation, and every single website content of Autogon AI, and this bot understands on how to communicate around that. But yeah, we've just built this other bot, and you can see the bot ID for those of you who want to call it via an API or via the SDK. Okay, we can already converse with our bots, and I could ask a question. Tell me about African. Tell me about what's the name of this book? African traditional medicine. Traditional medicine. So give this some time, and so next question will look at plants and plants to look out for in Africa that are highly medicinal, and then I ask questions as regards malaria and how can I cure malaria leveraging African traditional medicine. So yes, I hope each of these books addresses such. I just hope it addresses such. Okay, so we can see African traditional medicine is the first line of defense for most Africans with health issues, while Western medicine is viewed as superior and it's often pursued when possible, blah 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 blah. African traditional medicine repeats blah 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 blah. Okay, so just like yeah, so not just copying items from the PDF, I could ask questions in line with the context of the PDF, and it gives a very good justice to it. So now this is similar to what we have here. So you can see this Autogon AI chatbot. I can ask it different questions about each of Autogon AI services, about the documentation, about the pricing, contact information, about I can a business in whatever space wanting to leverage artificial intelligence. I can ask it, oh, tell me more about Autogon Studio Wizard. Okay, so when you copy and paste that chat link we showed earlier, you can see how fast it is. So here it's for test purpose, but here you have your bots very fast once you've deployed it like this. So Autogon Studio Wizard is a tool that allows you to create predictive models effortlessly, blah 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 blah. You can see, beautiful stuff. And also very important, when you select public models, you have your models run faster than when you select a private model. Yeah, so you want to take note of that. And yeah, you can see ask any question as regards Autogon AI. How can my fish pond or fish pond business leverage Autogon AI? You can even ask questions outside context and bring in AI, and the bot is smart enough to come up with something interesting. So we can see it generated something. Your fish pond business can leverage Autogon AI in several ways. Data analysis can analyze data from your fish pond business, such as water quality, fish behavior, feeding patterns. This analysis can provide insights to optimize your operations and improve fish health and growth. Beautiful. Predictive modeling. Autogon AI products can help you build predictive models to forecast fish growth, disease outbreak, market demand. This can assist you in making informed decisions about stocking, feeding, and marketing strategies. So you can see we have something beautiful. Then we can use it to leverage Autogon AI for your fish pond business. Upload, select the product, sign up, upload your fish pond data, train your model, and this is brilliant. So so this is the power of chatbot. You can build chatbots, customer service, robot advisor, grade 2 student trainer, a digital lawyer that handles divorce cases, and many more other challenges. So yeah, so those are super interesting stuff that we can do on Autogon AI, building smart chatbots in very short timeline. Thanks to interesting advancement in the area of generative AI, large language models. And yes, so we've come to the end of section 1. I see you at section 2, guys. Take care.